Okay, in this video, what we're going to do is talk about some of the more common light attributes you will be dealing with on a regular basis when illuminating a scene. Now, light attributes, there's a lot of them, and it can get quite deep.
Yes, it can.
It can get quite technical in understanding exactly what the attribute is changing and how it's going to affect your final render. The idea of this video is not to dive deep into light theory and all of the various attributes that are available. Instead, we're only wanting to introduce the more common attributes and show you what they do.
That's right.
So let's go and get started. You'll notice that we still have our incredibly cool Stonehenge cylinder type scene set up from the last video, and we will call on it to help us out in demonstrating some of these things. So let's go ahead and switch over to a lit mode. So I'll hit 7 on the keyboard. Ooh, nice and dark.
Dark and spooky.
Now let's go ahead and come up here to create, come down to lights, and I'm just going to call on a point light to get things started. Let's move it on up in the air. There you go. Now when thinking about lights, the first two attributes that come to mind that I would need if I was designing some sort of 3D program would be what, Zach?
Well, color would be one.
Color. You'd need to adjust your light color. And the other one would be
brightness.
Brightness. Some way to control the brightness. Well, it's really interesting how this works because the two of those kind of work hand in hand.
Sure.
Let's take a look. I'm going to hit the Control A key combination on my keyboard to bring up the attribute editor for my point light. And look at this. Color and intensity. And how does it work? Well, by default, our color is white. How often is a light really white in the real world?
Technically speaking, very, very rare.
Very, very rare. Well, guess what, Zach? Many beginners in the world of Maya love to leave their lights white.
I did when I was a beginner.
And, yeah, that's just not really cool.
No.
Let's go ahead and change our light color here. So you'll notice that as I begin changing this guy around, the light is indeed changing.
Yeah, it is.
So now it's scary and nighttime out at our Stonehenge area. As you can see, we're just adjusting colors. Yeah.
And now there's some kind of really cool funky music playing in the background.
Exactly. So anyways, one of the things to point out here is while I am indeed changing the color, by adjusting the value setting, I will be changing the brightness of this light itself.
Sure.
Let's go ahead and take the value from 1 down to 0.5, and you'll notice that our light color is not going to change. Instead, it's going to get darker.
Well, just, down there looking at the value, if you were to drag that all the way down to black,
darkness.
I mean,
darker.
There is no such thing as a real black light.
Darker.
Yeah.
There, so you get the idea. So let's go ahead and change this up to, actually, let's leave it at 0.5. I kind of like that because that's going to allow me to demonstrate intensity. And intensity is nothing more than a multiplier for the value found on color and directly affecting the brightness of our light.
That's right.
So if I was to take my intensity down to 0, if you multiply that by our value of 0.5, 0 multiplied by anything gives you 0. 0 means nothing. That means no light, and you'll notice here that it is completely black. Now, if I was to, let's say, turn it up to something like 20, you'll notice we now have a nuclear pink light. And, yeah, everything is now blinded, for sure.
SPF 9 million to walk out there.
Exactly. So using intensity, basically, you can work hand in hand with your value setting found in color to find the right brightness for the light. So let's go ahead and set this back to a value of 1. All right, moving right along, another attribute that you'll find very handy as you progress with your Maya skills is the Illuminates by default. What this means is anytime you create an additional piece of geometry in the scene, this light will illuminate that geometry by default. By coming in here and turning this off, what we've just done is we've made this light not illuminate anything in the scene at all. Let's go and turn it on real quick and demonstrate this. So I'm going to come up here, render my scene real quick. And, hey, what do you know? The light is indeed illuminating the scene. Now, let's just turn this off, and then let's come back over here and re-render the scene. And, yeah, check it out.
Yeah, it's a pretty distinct difference.
So at this point, there's some things I can do inside of Maya so that I can make special associations between the light and pieces of geometry so that I can illuminate only specific pieces of geometry. This is very handy and something we'll begin talking about in the next project. Once I start doing that and then I start creating additional pieces of geometry, by default, everything that we add in will not be illuminated if that checkbox is indeed unchecked.
That's right.
So keep that in mind. All right, let's go ahead and turn this back on because without it we can't demonstrate any of the lighting effects when we hit the render button. Moving on down from there, we've got Emit Diffuse and Emit Specular. What does this mean? Well, when you see light strike an object, and you see the color of that object, now you're dealing with the diffuse.
That's right.
The easiest way to look at it is, hey, I see the object. It's the basic color of the object
the
itself.
base color, that's right.
That's right. Now, what's the specular? Specular is your hot spot on it, okay, like we talked about in the last few videos.
When you change that specular highlight.
Yeah, it's the highlight. So we can control which of these elements are going to be visible on the geometry. Perhaps we wanted to add in a light that was only going to cause a hot spot to appear on a piece of geometry. We would want to turn diffuse off. Now, by default, Emit Diffuse and Emit Specular is on. Here's an interesting example. Let's say that I had a scene set up with a satellite, very reflective metallic pieces. Right?
Sure.
And of course, we've got the sun striking it, so it's going to have a very interesting hot spot for sure. Let's say that some of the solar panels weren't illuminated exactly how I wanted them.
Right.
So I added in an additional light to provide just an extra level of illumination, just kind of trying to do a light trick, if you will.
Right. Make it look like more light might be bouncing up off the surface of the Earth.
Precisely. Now, what happens? I just picked up a second hot spot. But now it's going to be like, we've got two suns illuminating our satellite. That's kind of odd.
Right.
In a case like that, I can come in here and turn the Emit Specular off and just use it more as an effect.
There you go.
So instead of a light source that the viewer of your final render can pick out where that light source would be at.
Right, and at the same time, maybe I'm rendering out like an automobile or a car that has to look like it's on some sort of a did you hear what I said? Automobile or car? So it's on like a show floor, and you want to have a lot of hot spots across the top, like it's got a lot of lights overhead, but you don't want to add too much.
You don't want to nuclear wash out your car.
You don't want to nuke your scene, so you could just flip the other switch.
For sure. So, moving on from there, we've got the decay rate, and this is going to be how fast our light falls off, how fast it diminishes over distance.
That's right.
By default, there is no decay, which simply means let's go ahead and move way back.
That's way back.
Is that way back, Zach?
When you get beyond the...
Now let's move the light way up.
Okay, good enough.
So the light's now up here at 6,000. Is that up far enough?
I think so.
Now let's come in here and render our scene. And here it comes. And so it is indeed illuminated.
Yeah.
So that worked out pretty well. Now what I'd like to do is, let's just come down here and change our decay rate over to, let's say, linear. So now the light is just going to continue to equally fall off linearly as the light gets further and further away from the source itself.
Are you planning on moving it back down?
So now let's render again, and you'll notice that our scene is in complete darkness.
That's right. I promise you. I promise you that's not an off switch for your light.
So now let's come back down to about 10. Yeah, maybe. Actually, 10's going to work out really well. Watch this. At 10, we can barely start to see anything back over here. So
I don't know how well it's going to show up on the video. It's there.
It's there. It's very subtle. Now watch this. Let's come over here and turn our intensity up to like, 25 for starters.
Ooh, there you go.
So now we can see some things, but look how bright. I mean, we're talking 25. So let's render this again, and now when we render it, we're going to see that much better looking scene. Okay, as a matter of fact, one of the things you're going to notice is that the quality of light is just going to feel better the moment you start using decay rates and all.
That's right, because in the real world, light does decay as it leaves its source.
That's right. So suddenly your render is going to look far more realistic when you start working with these decay rates, as opposed to everything being equally illuminated no matter how far away it is from the light.
That's right.
So now, of course, we can make our light drop off even faster. As a matter of fact, if we change this from linear over to quadratic, now we're dealing with light that is based on a model that's just like the real world.
Yeah.
So if we move over to this, light's going to drop off even faster. As a matter of fact, let's save this image right here, come back and render now. Remember, I haven't changed intensity. I haven't changed my camera setting. I've just changed the decay rate.
You can just barely see it.
Look at this. Let's go ahead and save this one as well. Look at the difference. So we've got that and that. Woo, big, big, big difference. So now to illuminate this over here, let's change it to about 75. Now let's do another render and take a look at this. So you can still see it's still very dim.
So you're really having to crank up that intensity.
Kind of like a campfire at night, but everything's washed out in green for some strange reason. So we'll save this one as well.
Okay.
But look at this. So a big difference when we jumped all the way up to 75.
Oh yeah.
Not really.
Well, I mean now you can.
You can see it, but
yeah.
It's not like we're blowing out the scene.
True.
Even by taking this and changing it up to something like maybe even 150. Okay, look at this. We're still, let's do 250. We're still not necessarily nuking the scene.
That's right.
And what I mean by nuking the scene is extremely bright. So let's render this again, and you'll definitely see we're illuminating the floor now, but we're still not blowing anything out with a major white area.
But the cool thing is you can see that light starting to decay as it leaves the source.
You sure can. And now check this out. So let's leave that at an intensity of 250 and change this over to cubic.
Ooh.
Now, a little bit of a change. But let's do the comparison. So we'll go ahead and do a quick render here. And, very noticeable back over here.
Yeah.
Very interesting looking detail, though, because the light is falling off so fast. So you can see as we compare between the two, much more noticeable in the final render than it is over here in the viewport. But be careful, because if I put this back over at quadratic, one of the things that's really, really important to consider is the scale of your scene.
Actually, that's going to be really important when you start playing with any light that has decay. Just consider, for example, you have a 4-inch by 4-inch box, and you strike a match inside of that. It's going to light up that box really, really bright.
Yeah.
It'll light the box on fire if you're not careful.
Pretty much.
Now, imagine lighting a match inside of an airplane hangar.
That's right.
Where the light probably won't even reach all the way to the walls.
That's right. I can't even tell you how many demonstrations I've given to students in classes before where I've talked about decay rates, and then they turn around and they start setting up their own scene, and they're like, hey, Buzz, look, man, I'm using quadratic setting for my decay rate, and it's like nuking my floor right here, and it's not illuminating anything back here, and so I'm going to have to turn my intensity up to 500 to even see any light back here, but by the time I do that, everything is so nuclear white close to the light, and as a matter of fact, I'll render this while I'm talking, and I'm like, really? Let's take a look at the scale.
Yeah.
Oh, gee, what do you know? That light is currently placed basically a half a centimeter away from the floor, and you've got its intensity. I don't know, in the real world, perhaps it's a 3,000-watt light bulb. Gee, I wonder why.
Nice.
So, yeah, you really need to think about scale. That becomes very important when you start dealing with decay rates. Another thing I have just got to say is this is a thing that goes missed by a lot of beginners. They leave all of their lights maintaining the same power over the entire life of the light. And how far is the life of the light with no decay? Well, forever. It just goes on forever. And you start mixing all your lights in like this, and you really, really do lose out on the realistic effects that you get by light that diminishes power over distance.
Not to mention, in like a complex scene, your lights are going to start tripping over each other. At some point, you need your light to quit so you can use another light.
And lights work together. Their colors blend together. I mean, you get some really nice effects. Light can introduce light into shadows, which is very handy. But again, it's important that you start thinking about drop-off rates or decay rates of lights. So just keep that in mind. For now, let's go ahead and take this back to no decay.
Actually, I was just thinking, you caught me off guard a second ago when you tried to get my attention, because I was looking at the screen and that white hot spot, for some reason, as soon as I saw it, I involuntarily squinted.
Let's go back to no decay. Quick warning, go ahead and put on your welding goggles now.
Boom.
So you'll notice if we took the time to render the scene right now, an intensity of 250 would give us with a cartoon-looking render like such.
Yeah, not even cartoon.
Yeah, really.
It's just like, wow.
So hopefully at this point you can tell the difference between the two. Thank you very much. Okay, so anyways, that's decay rate. Let's go and take our intensity back down to something
a little more manageable.
An intensity of 1. Now,
Jinx.
Let's go ahead and, I hear you. Let's move this light over here to the side and create another light. Let's come up here, light, and for just a minute, let's talk about other properties that you're going to see that are common and you'll find yourself working with. First of all, check it out. See, the lights are playing together nicely.
Oh, yeah.
When you work with a spotlight, you're going to find a cone angle, and you're going to find a penumbra angle. And you're not really going to see the effect of a penumbra angle at the moment with the way we've got the viewport set up. You can, of course, see it when we start rendering, but we're going to talk more about that in the next video when we start adding lights into the scene. So basically, there you go. I just wanted to show you that we can indeed control the cone angle. Again, lights are going to blend together. Right now we've got green going on back there. If I start making this red, you'll notice how they're working together. And now we've got a paler color at the moment. As a matter of fact, if we were to come back over here and create another light, and let's do another spotlight. And we'll flip this around this way and move it up and move it back up. And now our colors aren't true colors here, but I think we can start to get the idea. We'll go with more of a blue on that one. We can get this one here. It's pretty red.
This is getting scary, by the way.
And we can get this one here. We can come over here and get a nice bright green. And you can see, you can barely see. Actually, you can a little bit. Right in here, how we're starting to slowly head over more to a white color.
That blew me away the first time I ever saw it when I was a complete newbie to Maya. I was like, wow, the lights mix realistically.
Yes, they do.
But yeah, I'm easily impressed sometimes.
So yeah, big thing though, of course, the cone angle, penumbra angle. You see, we do have a decay rate. We also have a drop-off rate when dealing with spotlights. We'll talk more about that coming up a little bit later. And one more I wanted to show you in regards to just the generic light properties that are found only on specific light types, and that is something we've looked at already. That is on an ambient light. Of course, you can see how we just managed to wash out our entire scene. And that is the ambient shade. If you remember, we talked earlier about how this allows you to blend over to basically light that appears to be emitted from an infinitely large sphere to light that seems to be being emitted from this point, from where the icon itself is. Let's turn our intensity way down. And let's blend a little bit of that in there. That's right. Maybe a little bit less. Very handy, but very small settings. And the general color of the scene goes more towards the world of green. Yeah, there you go. So now you'll notice that when we render this out, it's getting a bit more interesting or scary.
It's still scary, yeah.
Yeah, there you go. Whichever way you want to look at it. Now, one more thing about light attributes before we call this video a wrap. That is shadows. Okay, let's go ahead and come back over here, grab our point light. Let's open up shadows. Now, shadows, in most cases, not all, but most cases, break down into two different categories. And you have to choose one or the other when dealing with a specific light. We've got depth map shadows, and we have ray trace shadows. They both generate shadows completely different.
Right.
Okay. So depth map shadows, it's a bit complicated how it works, though. We'll see if we give how deep of a lesson we give a little bit later on. I mean, this really is not an in-depth rendering class.
That's right.
But basically, depth map shadows is going to generate a depth bitmap that's used in determining where shadows will be. It's not quite as crisp as what you will get from ray trace shadows, where with ray trace shadows we're actually tracing the beam of light out of the point of emission from the light.
But naturally, it's going to be a whole lot faster.
But it's a whole lot faster. That's right. When we start dealing with ray trace shadows, then we start dealing with very accurate shadows, very sharp shadows. Yeah, that's pretty much all I want to say at the moment. Of course, ray trace shadows cost. They can become quite rendering intensive, but at the same time, so can depth map shadows if they're not set up properly.
Right. If you crank the settings up too high or just don't really keep track of what you're doing.
That's right. Now, depth map shadows and ray trace shadows are the only types of shadows available to us, and even with these things, there's all sorts of different settings that allow us to control everything from shadow color to the resolution of the shadow itself, and these are things we're going to be exploring more and more as we progress through this course.
That's right. I did want to mention, though, that you can use both types of shadows in the same scene if you want to.
Oh, absolutely, from different lights.
That's right.
But if you're going to tell a light that his job is going to be, let's say, I want you to do depth map shadows. And I come down here and I say, I want you to also do ray trace shadows.
That's right.
Look what happened.
You can only have one type of shadow at a time coming from a single light, though using multiple lights, you can use both kinds of shadows.
Absolutely, for sure. So anyways, with that, this video has been nothing more than just an introduction to some of the more common light attributes you're going to be dealing with on a day-to-day basis when working with lights inside of Maya.
Yep.
So at this point, I guess we're ready to go ahead and move on to our talented ball scene and throw a light in there.
Let's go.
So that's going to wrap up this video. Thanks a lot.